Hi everyone, I'm Yan Yan.
Konnichiwa, I am Marge.
Hi, I'm Cody Cueva.
Hello everyone, I'm James.
Hello! My name is Maiden.
And today we're going to teach you how to verify trigonometric identities. And we're going to show you through 3 examples.
So before we start verifying trigonometric identities, here are some of the values or equations to help you verify. So let's start off with the reciprocal identities, which is composed of sine x equals to 1 over cosecant x, and cosine x equals to 1 over secant x, and tangent x equals to 1 over cotangent x. Second is the ratio identities, which is composed of tangent x equals to sine x over cosine x, and cotangent x equals to cosine x over sine x. Third is the Pythagorean identities, which is composed of the sine squared x plus cosine squared x equals to 1, tangent squared x plus 1 equals to secant squared x, and 1 plus cotangent squared x equals to cosecant squared x. Lastly, we have the odd-even identities, which is composed of sine multiplied to negative x equals to negative sine x, cosine multiplied to negative x equals to cosine x, tangent multiplied to negative x equals negative tangent x, cotangent multiplied to negative x equals to negative cotangent x, secant multiplied to negative x equals to secant x, cosecant multiplied to negative x equals to negative cosecant x. So, all those formulas and equations that I stated earlier is all part of the table of the fundamental trigonometric identities. So this table is really helpful for you if you're verifying trigonometric identities. You may use the following formulas or equations to manipulate them into substituting them in the equation for verifying the trigonometric identities. You will understand what I mean later, but you always have to keep this formula or equations in mind. So this table is really helpful. I suggest you either memorize it, but of course we're only human. If you can't memorize it all, you at least can keep a copy of it nearby you or somewhere you can easily look at it. So let us now proceed to our first problem. Now, this is our first problem, which is secant y multiplied to cosine y equals to 1. So, what we have to do here is that we have to manipulate the equation on the left side, and we don't have to touch the equation on the right side at all. So, what I mean is this part, leave this as it. This is what we will manipulate, and this is what we will leave as is. So we have to make sure we manipulate this part to get this value. We have to get 1. So how do we manipulate secant y multiplied to cosine y to get 1? So let's check our table from earlier. If we look at this table, cosine here states from the reciprocal identities, cosine is equals to 1 over secant x. So with that in mind, let's go back to this problem. If we keep secant as is and substitute the formula of cosine, we will have secant y multiplied to 1 over secant y. So with this, we can already simplify it. So we will cancel out both the secant we will cancel it out. And when we cancel it out, we will have 1 is equal to 1, thus proving our case that it is indeed a trigonometric identity.
Off to our next problem. We have cosine x plus sine x times tangent x equals to secant x. So now, we have to manipulate this one to get secant x. How to do that? This would be as easy as the one we had earlier. For this, we have to consider the possible formulas or equations that may be equal to cosine, sine, and tangent. What we plan to do for now is just copy cosine x as is, plus sine x, and substitute tangent x because based on the formula, tangent is also possibly equal to sine x over cosine x. And copy the right side as is. With this for now, what I want you to do is try to simplify it first before substituting it. So it will be cosine x plus sine squared x over cosine x equals to secant x. After that, for this, you need to simplify it once again. We have to put this in one formula or equation. Multiply the denominator to the numerator, which makes it cosine squared x plus sine squared x over cosine x is equals to secant x.
To continue, now we have to check our formula. If you look at the Pythagorean identities, sine squared x plus cosine squared x is equal to 1. And we have that here. Since we have that 1 over cosine x, we can look again at our reference. 1 over cosine x, if we cross multiply it with secant x, is equal to secant x from cosine x equals 1 over secant x. Thus, we have secant x equals secant x. Therefore, we are able to verify this is a trigonometric identity.
So for number 7, the problem is cosecant x minus sine x equals cosine x times cotangent x. With this, cosine x times cotangent x will be the basis of your trigonometric identities. In this part of the equation, you'll be expanding cosecant x using the ratio identities. So it will turn into, or will be expanded into 1 over sine x minus sine x. And after you've expanded the equation, you'll be multiplying 1 over sine x to sine x, which will give you 1 minus sine squared x over sine x.
According to the Pythagorean identity table, 1 minus sine squared x is equal to cosine squared x. And now, it's cosine squared x over sine x. We should separate cosine squared x. We can do that by multiplying it with 1 over sine x. Going back to the Pythagorean identity table, sine x is equal to cosine x over cotangent x. Since we have an inverse of sine x, thus 1 over sine x will become cotangent x over cosine x. As you can see, we are now able to cancel out cosine squared x with cosine x, leaving us with cosine x and cotangent x. Thus, verifying this is a trigonometric identity.
And that's how you verify trigonometric identities. Thank you for watching, guys, and we hope that you have learned something from this video. Thank you and bye-bye.
Bye! Thank you for listening.
Bye! Thank you!
Good luck, guys! Sayonara!
Once again, thank you for listening and watching our video, guys.